Module 1, Lesson 7, Solve for Unknown Angles, Transversals. Now we start off here with some vocabulary. A transversal is a line that intersects two or more coplanar lines, and it intersects at distinct points. Now if we look at our diagram over here, our transversal T, and I like to make my transversals green, you can see that when it intersects line L and line M, that it forms 8 angles. So transversal T intersects lines L and M. Notice that angles 3, 4, 5, and 6, see them there, 3, 4, 5, and 6, lie between lines L and M. They are called interior angles. And angles 1, 2, 7, and 8, see them out there, 1, 2, 7, and 8, lie outside of our lines L and M. They are called exterior angles. And when our transversal intersects these lines, these angles that are formed are special. So let's start with our first ones here. Corresponding angles are on the same side of the transversal and in corresponding positions. So these are in the same place. So let's mark our transversal. There's our transversal, 2 lines cut by a transversal. And if you're going to mark your angles like I am, make sure that you are using different colors so you can tell them apart. So let's start with angle 1. Angle 1 is to the left of the transversal and above the line. So the next angle that is to the left of the transversal and above the line is angle 5. Angle 2 is to the right of the transversal and above the line, and so is angle 6. Now it works for the other side as well. Angle 3 is below the line and to the right of the transversal. So here we go, 7 to the right of the transversal and below the line. Angle 4 is also below the line, but it's to the left of the transversal, just like angle 8 is. Left of transversal, below the line. Now, corresponding angles, there will be 4 pairs of them, always. The others we're going to do only have 2 pairs. Let's look at our next one here. Alternate interior angles are non-adjacent. That means they don't touch. Interior and on the opposite sides of the transversal. So alternate interior angles are opposite inside, just like their name says. So if we look at our diagram and we mark our transversal there, alternate interior angles, we're going to have angle 3 is inside, and on the opposite side of the transversal, not adjacent, is angle 5, alternate interior. And angle 4 and angle 6 are also alternate interior on opposite sides and on the inside. So they're kind of diagonal. Next is same side interior angles. These are interior angles and on the same side of the transversal. So we find our transversal. And now this time, we look at angle 3. It's an interior angle. This time we want same side of the transversal, not opposite. So angle 3 and angle 6 are same side interior, just as angle 4 and angle 5 are same side interior, just like the name says. Our last set of special angle pairs here are alternate exterior angles. They are non-adjacent, don't touch, exterior angles, so outside, and on opposite sides of the transversal. So these are opposite outside angles. So we find our transversal, and now we are looking for outside angles. So one is outside, and we want the one that is opposite of that and outside, so that's 7. And angle 2 and angle 8 are opposite exterior angles. So you can see where they are by their names. A useful postulate that we have is the parallel postulate, and it simply says that through a point not on a line, there is one and only one line that is parallel to our given line. So let's say that we are given line L here, and then we choose a point not on our line, so point P, and we are able to draw a line that goes through point P that is parallel to line L. And there is one and only one line, exactly one line through P parallel to L. And we mark parallel with little arrow marks. That's how we know lines are parallel. If we're told they're parallel, we put those marks on. If we see those marks, we know the lines are parallel. What this allows us to do is draw an auxiliary line that can help us solve for unknown angles. We like parallel lines. Now to our important postulates and theorems. These special angle pairs that we just talked about, when they are formed by parallel lines that are cut by a transversal, they are congruent, supplementary, or both. And these relationships, congruent and supplementary, can also be used to prove that lines are parallel. So we'll see how this all works. Remember that postulates are accepted as fact, theorems are proven, and we will see the proofs of some of these in later lessons, 9, 10, and 11. And all of our postulates and theorems are if-then statements. Our if is our requirement, and our then is the result. If we have what's required, then we can go mark the things that we know are true. So, corresponding angle postulate. If our transversal intersects two parallel lines, so if we have parallel lines cut by a transversal, and remember, I like my transversal to be green, and parallel is always purple. That way I know which is which. So, my requirement is parallel lines cut by a transversal. My result, corresponding angles are congruent. So we can say that angle 1 is congruent to angle 5. Angle 3 is congruent to angle 7. And I'm not going to mark any more than that because it just gets messy. But again, corresponding angles, there are always going to be 4 pairs of them. So angle 4 is congruent to angle 8, angle 2 is congruent to angle 6. All of those could be marked. We know all of that is true. Now we have the converse of the corresponding angles postulate. Remember what converse means? We just flip our if and then statements. So our requirement here is that if two lines and a transversal form corresponding angles that are congruent. So we have 2 lines in our transversal right here, and we can see that our corresponding angles are congruent, then what's the result? We can say the lines are parallel. We can say that line L is parallel to line M, and we can mark them parallel. That is the result. Our next set of special angle pairs, alternate interior angle theorem. This is a proven theorem. You will see this proof later on. So if a transversal intersects two parallel lines, so again, if we have parallel lines cut by a transversal, here's our transversal, then what is true? Alternate interior angles are congruent. So we can say that angle 3 is congruent to angle 5, and angle 4 is congruent to angle 6. And then we have the converse of the alternate interior angle theorem that says if two lines and a transversal form alternate interior angles that are congruent, so here's our transversal, here's our congruent angles, then what can we say? The lines are parallel. So again, we can mark parallel lines. Are you seeing a theme here? Our same side interior angle theorem. If a transversal intersects parallel lines, so if we have parallel lines, here's our transversal, here's our parallel lines, then what's the result? Same side interior angles are supplementary. Okay, this one's a little different. So we are going to look at our same side interior angles here. Let's look at angle 3 and angle 6. We know that they are supplementary. So the measure of angle 3 plus the measure of angle 6 equals 180. Now, if you think about this, look at angle 2 and angle 6. Angle 2 and angle 6 are corresponding. So we know that they are congruent. And what do you see with angle 2 and angle 3? Do you see it right here? That is a linear pair. So that is how this one is proven. 2 and 6 are corresponding, making them congruent. 2 and 3 are a linear pair, making them supplementary. So that is going to make 3 and 6 supplementary as well. And also the same is true for 4 and 5 because they are same side interior angles. Okay, and the converse of the same side interior angle theorem, what's that going to say? If two lines cut by a transversal form same side interior angles that are supplementary, right here it says measure of angle 3 plus measure of angle 6 is 180, so we know those are supplementary. Then what is true? Yep, the lines are parallel. So we could mark them parallel. Again, I know you see the theme here. And the last one, alternate exterior angle theorem. If transversal cuts two parallel lines, so there's our parallel lines, there's our transversal, what do we know? Alternate exterior angles are congruent. So everybody's congruent except for the same side interior angles. So we can say that angle 1 is congruent to angle 7, and angle 2 is congruent to angle 8. 2 and 8 would be congruent. And of course, our converse says if two lines in a transversal form alternate exterior angles that are congruent, what's going to happen? Our lines are going to be parallel. So here's our transversal. Here are our congruent angles. They are alternate exterior angles. That means our lines are parallel. Very, very powerful stuff right there. Make sure you know all those. Some additional postulates and theorems that we need along the way here. The perpendicular postulate, this is basically like our parallel postulate, says through a point not on a line, there is one and only one line perpendicular to our given line. So if we have a given line L and we choose a point P, we can draw exactly one line through that point that is perpendicular to line L. Exactly one line through P that is perpendicular to line L. So it just allows us to draw perpendicular lines, just like the parallel postulate allowed us to draw parallel lines. So very useful when we need to draw a line. Now we will use these next three theorems later on, but it's good to have all of this in one place. Our first theorem here, it does not have a name, so you have to write it out, but it's an easy one. It says if two lines are parallel to the same line, they are parallel to each other. So let's look over here. We have line A is parallel to line B, and line B is parallel to line C. And you can see that, of course, line A would have to be parallel to line C. These are some very specific theorems. These are for perpendicular and parallel lines, so some special cases. This says if two lines are perpendicular to the same line, so we have our transversal here, and we see that line M is perpendicular to line T and line N is perpendicular to line T, then they are parallel to each other. So that means if both of these are perpendicular, we can go in and mark the lines parallel. And this is like the converse of the corresponding angle postulate. Do you see that there? Do you see that these are corresponding angles? And the converse said if corresponding angles are congruent, then the lines are parallel. That's exactly what this is. It's just we have not marked our lines congruent yet. That's how you prove this theorem. You can prove that right angles are congruent to each other and then use the converse of the corresponding angle postulate to prove that those lines are parallel. And the next one is similar. Our perpendicular transversal theorem, this one has a name, says that if a line is perpendicular to one of two parallel lines, so let's look at our diagram here. Here's our transversal. Line L is perpendicular to line N, and we know that L and M are parallel. Then what happens? Then it is also perpendicular to the other line. So if N is perpendicular to L, and L and M are parallel, then we can say N is also perpendicular to M. This is like the corresponding angles postulate. Again, we have parallel lines, so we know corresponding angles are congruent, but we don't have congruence yet. We simply have perpendicular, but that is how this theorem is proven, is we can prove that those angles are congruent, and then we can turn them into right angles, and by definition of perpendicular, they are both perpendicular. So a lot of really useful postulates and theorems in this section. Parallel lines cut by a transversal create extremely special angle pairs. We are going to have fun with parallel lines.